I'd like to say that it's good to be here on the western side of the country and see our peers and share experiences. So I'm glad to be here and learn from you guys and see if I can, highlight what we do at the MDTA. Well, I'll just go over the overview of the presentation today. I'll say a few words about who we are, where we're located, how many facilities we have, and go a little bit into details of how we do our inspections in our experience and give you a highlight of our inspection program. So MDTA, the Maryland Transportation Authority, is established in 1971. So prior to that, it used to be the Maryland State Commission back in the days, and then we have a sister agency, the State Highway Administration, which is the state engineer, and we're like treated as another agency. The State Highway Administration has a significant amount of number of bridges in numbers, but we have the larger signature bridges in our inventories. So MDTA is responsible for constructing, managing, operating, and maintaining the state toll facilities. We have 8 facilities in the state, so everything that doesn't fall under the toll facilities is inspected and managed by the State Highway Administration. So we follow similar procedures like the State Highway Administration, follow FHWA inspection requirements when it comes to what we do. And we also deal with new projects, financing new projects, which could be a new facility or a new express toll lane. So that's our responsibility. So a little bit of our map there, but I'll go into the different facilities that we have. So those are the 8 facilities that we have. In case anyone doesn't know where Maryland is, it's close to Washington, D.C., right here. And on the north, we have Pennsylvania over there, Delaware here. The Potomac River separates us from the state of Virginia and West Virginia on the west side, and Washington City at the south. So we have 8 facilities, and just to show you where we are, we have I-95 here, starting at the north, at the Delaware, state line, and it goes all the way to the city, Baltimore City. So all that stretch of I-95 is managed by MDTA. And then we have 2 tunnels here that follow after that. The Fort McHenry Tunnel, which is a continuation of I-95. It passes through the city of Baltimore, and we have a little bit of stretch of the highway that goes after that. And we have another tunnel, I-895, which is kind of a byway for the Fort McHenry Tunnel. Going back to the north side of the state, we have a US 40 over Susquehanna River. That's a truss bridge that we own. Going south, we have a Francis Scott Key Bridge. It's I-695, the beltway around the city. And way south, we have the Nice Bridge here. The newest facility that we have, the Inter-County Connector, connects 2 counties, and it's the first all-electronic toll facility. So there's no toll booth or anything. It's all electronic. These are the overview of the facilities. I'll just show you some of our signature bridges. I don't want to bore you with details, but our biggest bridge, our bridges, the eastbound and westbound bay bridges. So they carry US 50 and US 301 over the Chesapeake Bay. Some people confuse it with the Chesapeake Bay Bridge and Tunnel in Virginia, but it's different. I've seen some newspaper articles where they show the picture of our bridge when they have an accident in Virginia. So we try to say, oh, not Nara Bridge. It's the same Chesapeake Bay, but a different bridge. So these two bridges, each of them are 4 miles long. So it's a lot of concrete. One of them, the eastbound, is a 2-lane bridge. The westbound is a newer bridge, 3 lanes. But these are not adequate for the traffic that we have here. So we hope to have a third bridge, but you can imagine how expensive that is. A 4-mile bridge is really expensive. These were built in the good old times when they costed about a few $100 million. But today, you can imagine how expensive it would be to build this. So, and this is our most complex bridge, both of them. We have different subunits in there. We have simple beam spans, we have built-up girders, we have deck trusses, suspension spans, and through trusses. The other big bridge, signature bridge we have is the Nice Bridge. It's located at the south. It carries US 301 from the state of Maryland to Virginia. It's about a mile long, a little bit more than a mile. This bridge actually is due for replacement in 2018. We plan to replace that in 2018. It's one of our old bridges, so pretty soon we'll have a new bridge. Always good to have a new bridge. As an inspector, you have less headaches with the new bridge, so hopefully all goes well. Moving on to the other bridges, we have the Tidings Bridge. It's I-95 over Susquehanna Bridge. We have also Haddam Bridge, which is parallel to it on US 40. Both of them are about a mile long, the Haddam being a little more than a mile long. The Key Bridge, you see it on the right side. It's about a little less than 2 miles. So you see that we have big bridges to deal with. So when you compare the surface area or the deck area, we may as well have as much as the State Highway Administration, even though the number of bridges is almost 325. We have 2 tunnels, I-95 and I-895. One of them, the Fort McHenry Tunnel, it carries 8 lanes, so 4 lanes in each direction, north and south. And Baltimore Harbor Tunnel carries I-895, and it's a 4-lane tunnel, about 2 miles, a little less than 2 miles long. So these are not as complicated as some of the bridges MassDOT has, or you guys have here in Washington, but they are underwater, so they have their own challenge. So other structures we have, according to the Federal Highway definition of bridges, almost 325 bridges. And we have 1,200 other assets, ancillary structures, sand structures, small structures, retaining walls, and all the like. So all these fall under our inspection program. So a little bit of history. Going through files, I found some reports that date back to 1941. The one you see on the right is the first annual report. And it was interesting because you see, we all know that the inspections formally began after the Silver Bridge collapse in 69 or 68, but it was good to see some condition inspections that date back to 1941. MDTA established in 1971, so the first inspections were submitted to us in 1972. But we have annual inspection reports since 1941. This is partly because of the trust agreement that we have with the Bank of New York. As it's a toll facility and revenue generating, we have investors who have interest in the assets as well, in addition to the public safety. So we are required to have annual inspections of our facilities to make sure that they are in good condition, repair and working order. So We appear to have a more stringent inspection requirement compared to, maybe other agencies. But that's a good thing. So over the years, we follow FHWA and the state's engineers' requirements, closely follow that. We just may do a little bit more inspection than what they do. So back in 2009, we did a major overhaul of the inspection program, where we come up with a strategic plan on how we deal with our deficiencies in our bridges and tunnels. And we started having a facilities inspection manual, which later on I will go into details about the manual itself. And we had our own asset management software. We utilized to collect inspection information and also other information related to repair recommendations, contracts and the like. So generally, we want to make sure that our assets are in good working order, condition, and repair. Mission is making sure that we identify deficiencies, provide accurate reports, and comprehensive data. We also strive to coordinate activities in a timely manner so that deficiencies are corrected in time before they become too costly or too damaging. So at the forefront of our mission is efficiency and effectiveness, and it's sometimes you all know how difficult it is with inspections, with the managing traffic, managing costs. These two are important. So try to do things right the first time, and we try to do it right. So we try to tell our inspectors to remember these two things in their planning and execution of the inspections. So we try to have a proactive approach and try to not to let our assets, deteriorate. So we have, based on that, 35% of our bridges are 50 years old or older, but more than 90% of our bridges are maintained with the lowest NBI rating of 6. So we try to build on that and keep them on the good conditions that they are in. But doesn't mean that we don't have our own bridges with headaches. I know that we're not supposed to use that word anymore, SD. So I'll try to say that we have one bridge with a deck condition rating of 4. We will replace in 2018. It's about a mile long. It's a viaduct. It goes from the I-8 695 tunnel and goes north on that byway. So one out of 325, I guess, is a good percentage. It's less than 0.5%. So we have I believe a good we can say that our assets are really in good condition. So we have the asset management program we started in 2009, 2008, and we believe that with the tracking of repairs and deficiencies we utilize using that, we've managed to reduce a significant amount of our repairs over the last 4 or 5 years. How do we do it? As I said earlier, the trust agreement requires us to utilize, to do inspections every year. Not only that, we're required to utilize independent third-party, nationally recognized engineers or engineering firms to do our inspections. So that has resulted in our inspection requirements being a little bit more stringent than the minimum federal highway required qualifications. We don't have a lot of in-house engineers, including myself. We are 3 in-house engineers, but we have a lot of consultants who help us with our inspections. We have 4 joint ventures of consultants and sub-consultants and vendors to supply us with, equipment and MOT access. My last count, about 125 or 24 inspection team leaders, which should meet that requirement. A bachelor's degree in engineering, they should be registered as professional engineers, and they should take all the FHWA required NHI courses. And if they are inspecting the complex bridges, they need at least 5 years of experience. So pretty stringent inspection report, but that helps us get pretty detailed and good reports that include not only condition, but also repair recommendations, including the priority. I'll go on details about the priorities that we have, and we, the inspectors set those priorities, but we review that and concur or revise from the in-house team. In order to do that, we have our inspection manual. It's a document about like 700 pages long, and excluding the appendices. So it outlines our requirements, and it's useful as a scope. Like it tells us what the scope is. Whenever the consultants come in, you should do the inspections in accordance to the latest edition of the inspection report. So that helps us with that, and also provides guidelines on some of the detailed things that they need to do. Table of contents is there, so it covers a wide variety of topics here, and we revise that from time to time. We also have training and also constant communication between the inspection teams and our program. We do trainings for the team leaders twice a year at the beginning of the inspection cycle, which is usually around September, and around February we do another one to update everyone of what changes there are and if there's anything they need to focus on. We supply our teams with inspection bulletin that you see on the right. Some of it is reminding them of what they need, reinforcing or reiterating some of the things that they already know, and some of them are updates on any new requirements, either from Federal Highway or the state's DOT or other new technologies that they can consider in their inspections. So we find that useful. It's a quarterly bulletin, and it really helps bring everybody on the same page. I perform a biweekly inspection progress meetings with the PMs of the 4 JVs that lead those 40, 50 teams, and supply any additional training. Like when we started the element level inspection, there was some confusion on how to code painting. So we brought in paint experts to give them a good training on how it should be coded in order for us to get the most out of it. So we follow the FHWA standards, the trust agreement that we have with the Bank of New York, and our own requirements. So we gather details of condition, and also in our inspection reports have recommendations, repair recommendations with the associated priorities. This helps us minimize the additional field visit required for design. So most design or rehabilitation plans can be completed without additional field visits, because a lot of detail is documented in the inspection report. We follow that same NBI rating, 0 to 9, pretty much everybody knows this. What we have done in addition to that is you have an NBI for the overall bridge usually, right? But we have expanded on that and say, give us a span by span rating of the deck, the superstructure and substructure. Because we may have some bridges which have 50 spans, 100 spans, so one number cannot really represent the entire bridge. So span 45 may be the one which is, an NBI of 4. The other spans may be 6s. So that helps us identify exactly where the problem is. In addition to that, in addition to saying deck, super and substructure, we have divided the deck into the sub-elements. So you have the wearing surface, you have the fascias, all the other components, and all those are coded span by span for the different conditions. So you know exactly where the problem is. So this is before the element level, but now with the element level, we're trying to associate those two and see how those two work together. And the NBI rating, we have, used our manual to come up with condition, scales for other elements. These are the sub-elements. In addition to that, we have other structure like sign structures or retaining walls. We've modified the language, and we have some consistent rating for other structures as well. Element data, it's no more new, so most people are familiar by now. We use the AASHTO manual, like everybody, and we provided additional guidelines on how to compute quantities, to assign condition states for the different elements, and we have some agency-defined elements as well. NTIS, we're getting close. We're currently doing the biennial inspections for the tunnels, so our plan is to complete an NTIS compliant report hopefully by the end of the year. So the data gathering has been done so far. We're working on our software, inspection software, to fit in with the new requirements. Previously, we treated the tunnels just like bridges, and we added some elements, but they followed the bridge data collection. But with the new NTIS, we're modifying our software so that we can have the new NTE elements and our own ADE elements for the tunnels. So we're learning from the experiences we had when we developed our system for the bridges, and hopefully we'll probably have a better system now which utilizes the maximum benefit, because we have elements now for tunnels, and previously for the bridges, the element level data was kind of separate, but now with the tunnels, we're trying to merge the element level data with the condition notes so that you can see side by side. You have the element, you have the condition, you have the repair, and you have the condition state quantities as well. So the SNIDI is really organized in terms of the elements. If you look at the SINA for bridges, you have a lot of attributes or items, and trying to remember the 100 items is really difficult, and the numbers are all over the place. But the tunnel elements are more organized because the edge, the identifiers, the different structures, civil, mechanical. So it's really well organized. So we're gonna build on that and then have a better sense of the condition of the tunnels. An example of one requirement we have that is really helpful and I wanted to share is we inspection condition notes to follow the loser method. What it means is it should include location. By location, we should have a measured distance from a bridge element or point. So like in the example that with that color designation, you say, this many feet from the edge of the pier or from the abutment. The orientation is the direction of deficiency. Is it vertical? Is it horizontal? Severity. It's how the magnitude of the deficiency, and the extent over how much area, over how much length is that deficiency observed, and finally the repair recommendation with appropriate repair item and also appropriate priority in terms of whether that needs to be done right away or it's more of a less something that can wait for a few years. So you can see there, I tried to color code it so that it matches those 4 or 5 attributes. And we have also specific requirements about what photos need to be taken for what type of condition notes. It's a pretty detailed thing, but it helps us get good reports in the end. Repair recommendations. I was talking about the condition notes so far. We have one we don't want to have, emergency. We have a code for that. It requires immediate action. The first priority, we call it priority 1. These are mainly safety or safety-related or structural-related deficiencies. A second one, moderate deficiencies, usually on non-structural members. And the third one is the priority 3, which is serviceability-related issues. We use repair IDs. So each repair has its own ID, so we can track it. It tells us the year it was first identified. So you can see at the right, it says 2017. So that must be identified this year. So it's got the structure number in it and a sequential number. So we use that to designate the repairs and track them, how long they have been open, what priorities they have, how the priorities changed from year to year. We have specific procedures for emergency inspections, and that's outlined in our manual. And we have what we call, between emergencies and priority 1 repairs, what we call letters of concern, where if it needs immediate attention, it's not an emergency, but it's immediate attention, then we have also procedures for that. Repair priorities, it's something of a scheme. If it's a priority 1, we try to, have it addressed within a year or send it to construction within a year, evaluate it within a year. If it's a priority, a lower priority, then our system preservation program handles it. And others, maintenance-related issues, would be handled through our preventive maintenance program, where our districts or operations handle that. So this is an example in the manual. Like, we put in pictures, examples in the manual to help our inspectors assign the appropriate priorities there. More on repair recommendations. The challenge we have is, you want to have consistency, but you also want to have engineering judgment applied by the inspectors. So those are a little bit conflicting sometimes. The more prescriptive you are in your requirements, the less engineering judgments that you can get. So we try to juggle between the two and try to utilize a holistic approach where instead of focusing on specific details, of repairs, we step back and see, okay, what's the cause of this problem? Are we giving the appropriate type of repair recommendation? If we don't address the cause, then we just zooming in and looking at the specific repair. So we do bridge tours, in-house team, and some team leaders go out and look at the bridge and then see which bridges need to be, programmed for rehabilitation. So we supplement that with some of these activities. I will go through this, quickly, a little bit of details about the type of reports that we do. I don't want to bore you with details, but these are some of the things that we have in the manual in terms of specifying the inspection report types. We have review processes that makes sure that we have good reports, and we have audit inspections where teams inspect each other's field findings and also reports to make sure that we have good reports. And we also avoid having the same team inspecting the same bridge for more than 2 years. That's kind of our own way of making sure that we have quality inspections. We do this with, with our own system software. It's called the Authority Structures Inspection and Repair software, and it has different modules. It has the inspection modules and also repair modules. It's custom built to our needs, so it's powerful. It has its challenge, but it's really powerful, and it lets us track data and store information, generate reports, and also communicate between teams, send alerts to, myself and other team leaders. Just an overview of, we have inventory and inspection capabilities, just the things that I mentioned. These are some pictures from our data. It filters with, the different types of assets. If you want to look at just bridges, then you can look at bridges. If you want to look at bridges with a specific requirement, with NBI of 5 or less, then you can see that. So it's a really powerful thing, and we're building on it, and we're using the tunnel. We're adding to this a tunnel NTIS compliant features as well. This is the repairs. This is how we track them in the system, and a lot of information there. So it's just an overview here. Task orders or package of repairs into manageable work. We manage that as well with the status, cost, and all relevant information. So all this is, within one system. So it's good. This is our element data, and we can filter through this. We can filter by element. We can filter by span. So it helps us a lot with managing the data as well. Things under progress. We're trying to build from, inspection data and repair data into asset management or deficiency prediction or deterioration model in the system. So hopefully in a couple of years we'll have a really more powerful system to not only know what the condition is now, but also predicting which bridges would be, needing attention in the next 5, 10, 15 years and so on. This is the summary of the ongoing modules, new modules. The bridge tour module is what manages what we do when we go out as a team, in addition to the annual inspections. We're building on deck rehab module, paint module, and an overall asset management module.